So, in the previous chapter, we have studied the interior of the Earth. Now we are going to study distribution of ocean and continents. So basically, there are five continents, seven continents, and five oceans. So you are already familiar with the world map. You know that the continent covers 29% of the continent covers how much? 29% of the surface of the Earth. That continent covers 29% of the surface of Earth, and the remainder is covered by oceanic waters. The remainder is covered by that means 31%. The position of the continent and the ocean bodies, as we see them in the map, have not been the same in the past. Moreover, it is now well accepted that oceans and continents will not continue to enjoy their present position in times to come. Yeah, this is so. The question arises: what were their position in the past, and why and how they changed their position? Even if it's true that the continents and ocean have changed and are changing their position, you may wonder as how scientists know this. However, how have they determined their earlier positions? You will find the answer of some of these and related questions in a chapter. First is the continental drift, like a minor drifting of continents, like they are drifting apart. First of all, they were all in one there was one continent. That's what paranormal. I think a good name was there given to this continent. Let's find out what its name was. Observe the shape of the coastline of the Atlantic Ocean. You will be surprised by the symmetry of the coastline on either side of the oceans. No wonder many scientists thought this similarity and considered the possibility of two Americas, Europe and Africa, to be once joined together. From the known record of historic science, it was Abraham Ortelius, a Dutch map maker who first proposed such possibility as early as 1596. Antonio uh, Pellegrini drew a map showing these three continents together. However, it was Alfred Wegener, a German meteorologist, who put forth a comprehensive argument in the form of the continental drift. Continental drift theory in 1912. This was when I think World War was going to start. This was uh, this was this was regarding the distribution of ocean and the continent. According to Wegener, all the continents formed a single continent mass. Paniga. Yeah, that's what's the name of it. Paniga. Paniga. According to Wegener, all the continents form a single continental mass and mega ocean surrounded the same. The supercontinent was named Pangaea, Pangaea, which meant all the Earth. The mega ocean was called Panthalassa. The mega ocean was called Panthalassa, which means all water. He argued that around 200 million years ago, the superior continent, Pangaea, began to split. Pangaea first broke into two large continental masses as Laurasia and Gondwana land, forming the north and the south, forming the northern and the southern component respectively. Subsequently, Laurasia and the Gondwana land continue to break into various smaller continents that exist today. A variety of evidence was offered in support of the continental drift. Some of these are given below. Evidence in support of continental drift. The matching of continents. Jigsaw fit. The shoreline of Africa and South America face each other have a remarkable and unmistakable match. It may be noted that a map produced using a computer program to find the best fit of the Atlantic margin was presented by Bullard in 1964. It was using a computer program to fit a jigsaw puzzle to exactly show how the continent looked 200 millions ago. 100 millions years ago. It is proved to be quite perfect. The match was tried at 1000 phantom lines instead of present phantom lines instead of present shorelines. Rock of 3 majors across the ocean. The radiometric dating The radiometric dating developed in the recent period have facilitated correlating the rock formation from different continents across the vast ocean. The belt of Asian rock, the belt of Asian rocks of 2000 millions of years from Brazil coastline matches with those from the Western Africa. The earliest marine deposits along the coastline of South America and Africa are of Jurassic age. This suggests that the ocean exist did not exist prior to this time. Kinetites. It is a sedimentary rock formed out of deposition of glaciers. The Gondwana system of sediments from India is known to have its counterpart in six different land masses of southern hemisphere. Gondwana system of sediments from India is known to have its counterpart in six different land masses of the southern hemisphere. At the base, the system has thick tilitite indicating extensive and prolonged glaciation. Wow. Counterpart of this succession are found in Africa, Falkland, Island, Madagascar, Antarctica, Australia. Overall, resemblance of the Gondwana type sediments clearly demonstrate that these land masses have remarkable similar histories. The glacial tillitites provide unambiguous evidence of paleoclimate. Evidence of the glacier tillite provides unambiguous evidence of paleoclimate and also the drifting of the continents. Now, the next one is placer deposit. The occurrence of the rich placer deposit of gold in the Ghana coast and the absolute absence of the source rock in the region is an amazing fact. The gold-bearing vents in Brazil, and it's obvious that the gold deposit of Ghana are derived from Brazil plateau when the two continent lay side by side. Like he's saying that in the Ghana coast, the golds which are found, and in the Brazil, in which the golds bearing vents are found, they are like almost similar when they were in the same land, like 200 millions years ago, before the continental drift. Distribution of fossils. When identical species of plant and animal adapted to living on land or in fresh water are found on either side of the marine barriers. A problem arises regarding accounting of such distribution. The observation that lemur occurs in India, Madagascar, and Africa led to some to consider a contiguous landmass called lemuri, linking these three land masses. Basically, all the three this animal lemur was found in Madagascar, Africa, and India. Uh, Minosaurus was a small reptile adapted to shallow brackish water. The skeleton of these are found only in two localites, the Southern Cape provinces of South Africa and Irauer Formation of Brazil. These two localites are presently 4,800 kilometers apart with an ocean between them. Forced to drifting. Vaniga suggested that the movement responsible for the drifting of continents was caused by pole fleeting force and tidal force. The pole fleeting force related to the rotation of Earth. You are aware of the fact that the Earth is not perfectly square. It has a bulge at the equator, and this bulge is due to rotation of Earth. The second force is that was suggested by Wagner, 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 the tidal force is due to attraction of the moon and the sun that develop the tides in oceanic water. Wagner believed that These forces would become effective when applied over many millions of years. However, most of the scholars consider this force to be totally inadequate. So, most scholars post-drift studies. It is interesting to note that the continental drift, most of the evidence was collected from continental areas in the form of distribution of flora and fauna. Continental drift. It is interesting that the continental drift, most of the evidence in the continental drift, most of the evidence was collected from the continental areas in the form of distribution of flora and fauna or deposits like tinitite, tillites, tinitite, tillite, tillites, tillites. A number of discoveries during the post-World War period, Second World War period, added new information to the geological literature, particularly the information collected from the ocean floor mapping. Mapping provided new dimension for the study of distribution of ocean and continents. Conventional current theory. Arthur Holmes, Arthur Holmes in 1930 discussed the possibility of convection current operating in the mantle portion. This, these currents are generated due to radioactive elements causing thermal differences in the mantle portion. These currents convection 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 currents generated due to radioactive elements causing the thermal differences in the mantle portion. Holmes argued that there exists a system of such currents in the entire mantle portion. This was an attempt to provide an explanation to the issue of force, on the basis of which the contemporary scientists discarded the continental drift theory. Wow. Mapping of ocean floor. Detailed research of ocean configuration revealed that the ocean floor is not just a vast plain, but it is full of relief. Expedition to map the oceanic floor in post-World War II period provided a detailed picture of ocean relief and indicated the existence of submerged mountain ranges, as well as deep trenches, most located closer to the continent margins. The mid-oceanic ridges were found to be most active in terms of volcanic eruption. The dating of rock from the oceanic crust revealed the fact that they are much younger than the continental areas. Rock on either side of the crest of oceanic ridges have equidistant location from the crest, but found to have remarkable similarities both in terms of their continents and their ages. So, ocean floor configuration. In this section, we shall note a few things related to ocean floor configuration that help us in understanding of distribution of continents and ocean. You will study the detailed ocean floor relief in chapter 12. The ocean floor may be segmented into three major divisions based on the depth as well as form of relief. These divisions are continental margin, deep sea basin, and lastly mid-ocean ridges. So here we have ocean floor. So the deepest part of ocean, that is almost 10 kilometers deep. Okay, around 5 kilometers we have the ocean basin floor, average depth. The continental shelf is also continental shelf, that is below the ocean. This is a continental slope that gradually goes down, and it also makes the oceanic floor. Okay, average height, highest mountain. Okay, we got the gist of it. Continental margins. These form the transition between the continental shore and deep sea basin. They include continental shelf. They include continental shelf, continental slope, and continental rise and deep ocean trenches. Of these deep ocean trenches are the areas in which are the areas which are considerable interest in so far as the distribution of ocean and continents is concerned. So, abyssal plains. These are extensive plains that lie between the continental margins and mid-ocean ridges. The abyssal plains are the areas where the continental sediments that move beyond the margins get deposited. Abyssal plains are areas where the continental sediments that move beyond the margins get deposited. So, distribution of earthquakes and volcanoes. Study the map shown in the distribution 4.2. You will notice there is a line of dot in central parts of Atlantic Ocean almost parallel to the coastline. It is further extended to the Indian Ocean. It bifurcates a little south to Indian subcontinent with one branch moving into East Africa and other meeting meeting a similar line from Myanmar to New Guyana. So we are talking about India. So these are the lines. So deep sea earthquake zone. Shallow. These are shallow earthquake centers. Like these are lines. Like I think these are fault lines where tectonic plates and all will be there. Yeah. And the deep earthquake zone. See these lines. These are a deep earthquake zone. These. It's not line. It's particularly these areas. And in these areas, like deep, the volcanic eruption is also there. Small volcanic eruption. And these are the hotspot zones. So most of the hotspot zones are in ocean itself. The ocean we have 31% of the land is. Okay. You will notice that these lines of dot coincide with the mid-oceanic ridges. The shaded belt zone, the shaded belt showing another area of concentration coincide with the alpine Himalaya system, the rim of the Pacific Ocean. Pacific Ocean. In general, the foci earthquake, the foci of the earthquake in this area of the mid-oceanic ridges at a shallow depth, whereas along the alpine Himalayan belt, as well as the rim of the Pacific Ocean, the earthquakes are deep-seated ones. The map of volcanoes also shows a similar pattern. The rim of Pacific is also called as rim of fire due to its existence of active volcanoes in this area. Concept of seafloor spreading. As mentioned above, the post-depth studies provided considerable information that was not available at the time of beginner put forth this concept of continental drift. Particularly, the map of the ocean floor and paleomagnetic studies of rock from oceanic region reveal the following fact. First, it was realized that all along the mid-ocean ridges, mid-oceanic it was realized that all along the mid-oceanic ridges, volcanic eruptions are most common, and they bring huge amount of lava to the surface of these area. The rocks equidistant on either side of the crest of mid-ocean ridges show remarkable similarities in terms of period of formation, chemical composition to the mid-oceanic ridges. Sorry. The ocean equidistance on either the rock equidistance, the rock equidistance. I guess these are the ridges, and along these ridges, like we have small mountains which are formed due to volcanic eruption. That's why we have mainly on these lines we have hotspot zone, and also is volcanic eruption, which are forming oceanic ridges. Okay, the rock closer to the mid-ocean ridges have normal polarity and are younger. Are youngest. They are youngest because due to formation of the land from under the ocean, and due to volcanoes, also due to volcano. The age of the rock increases as one moves away from the crest. The ocean crust rock are much younger than the continental rocks. The age of the rock in oceanic crust is nowhere more than 200 million years old. Some of the continental rock formation are as old as 3,200 million years. The sediment on the rock floor are unexpectedly very thin. Scientists were expecting if the ocean floor were as old as a continent, to have a complete sequence of sediment for a period of much longer duration. However, nowhere was the sediment column found to be older than 2,200 million years. Well, this is 3,200, almost 60 times older. The deep trenches have deep-seated earthquake occurrence, while in the mid-oceanic ridges, the quake foci have shallow depths. Shallow. These are the shallow ones. These fact and detailed analysis of magnetic property of rock in either side of the mid-oceanic ridges have led as 1961 to propose this hypothesis of sea floor spreading. Has argued that constant eruption at the crest of oceanic ridges caused the rupture of oceanic crust and the new lava wedge into it. I told earlier, which is the oceanic crust on either side, from left and right. You get the gist. The ocean floor thus spread. Younger age of oceanic crust, as well as the fact that the spreading of one ocean does not cause the shrinking of other. So these are the mid-ocean ridges. Oceanic crust, subdued atmosphere. So where we reach atmosphere? Hotspot, shield, stratus volcano, convenient continental crust, ocean crust. There is ocean crust and the continental crust. Okay. Think about the consumption of the oceanic crust. We further maintain that ocean floor get that get pushed due to volcanic eruption and the crest sink down at the ocean trenches and get consumed. So I mean the sea level at this ocean where the ridges are there, from there we get eruption due to volcanic eruption, and the materials which gets out like lava and all that all get sedimented in these trenches. The basic concept of sea floor spreading has been depicted in 4.3. So, so as per the diagram or the figure, you can see that like 5400 or 540 millions years ago, the continent was not one, but it got slowly it got into one continent. Here, then here, here to here, here to here, to here, and currently here. Again, it's got distributed in the motion of continent during the possibility Siberia, India. We should connect to position of continent to geological past. Concept term plate, the plate tectonics. Since the advent of the concept of sea floor spreading, then the interest in the problem was distribution of ocean and continent was revived. It was in 1967, Mackenzie and Parker and also Morgan independently collected the available ideas and came out with another concept called plate tectonics. Tectonic plates are called lithospheric, also called lithospheric plate, is a massive and irregular shaped slab of solid rock, generally composed of both continental and oceanic lithosphere. Plate move horizontally over the asthenosphere as rigid unit, like a single unit over the asthenosphere. Move horizontally over the atmosphere as a single unit. The lithosphere include crust and top mantle, with its thickness varying from 5 km to 100 km in the oceanic part and about 200 km in continental areas. So 5 km to 100 km in the oceanic part and about 200 in continental areas. Plate may be referred to as continental plate or oceanic plate depending on which of the two occupy a large portion of the plate. Pacific plate, Pacific plate is largely an oceanic plate, where the Eurasian plate may be called a continental plate. Okay. The theory of the plate tectonic proposes that the Earth's lithosphere is divided into 7 major and some minor plates. Young fold mountain ridges, trenches, or the fault surrounding these major plate. Young fold mountain in 4.5. So young fold mountain is young young fold mountain stages. Fold mountains, right? He's talking about this one. These divergent boundaries, like divergent means it's separating and converging means it's making two boundaries into one. So we have this one. So as per the theory saying that these are separating, these are like making it into one. So as per this, the whole India was never a part of this whole Asia. So in somewhere in time, it got drifted and got attached to this and like convergent. That's why they converged, and due to this, it made some mountain ranges. I think Himalaya got made. That's why it is called Young Fold Mountain. So it, Himalayas are one young fold mountains, basically. Okay, Antarctica and the surrounding Antarctica and the surrounding oceanic plate, Northern America, with Western Atlantic floor separating the south, separated from South America plate along the Caribbean states. Caribbean. These are the Caribbeans. Mm, India, Australia, New Zealand plate. Australia, India, Australia. Okay, okay. These are all single plates. And New Zealand also. This plays part. New Zealand. These form a single unit. Okay. So Africa, like this one. This is the Africa. North Africa with a lot of Pacific plates. Pacific plates. This one is Pacific plates. This whole region is a Pacific plate. There is one more plate. So actually these are the area like divided it. These are the area. See Indo-Australian plates. These are Philippine plates. This is whole area is Pacific plate. And this is Caribbean plate. And Nazca plate, Antarctica plate, Scotia plate, like these are Scotia plates. No, this is South America plate. Scotia plate is just in this one. Mid-Atlantic regions. Arabian plate is just secluded in this one. This whole area is Eurasian plate, and so on. Nazca plate. Okay, we have already seen this. Caroline plates between Philippines and Indian plates, not to Nirvana. These plates has been consistently moving over the globe throughout the history of Earth. It is not a continent that move as believed by beginner. Continents are part of a plate, and what move is the plate. Continent is a part of the plate, and what move is the plate. Plates are moving, not the continents. Moreover, it may be noted that all the plates, without exception, have moved in geological past and shall continue to move in future as well. Beginner also Wagner also had thought of this continent to have initially existed as supercontinents. He thought it was a supercontinent that would have initially existed supercontinent on the Pangaea. However, later discovery revealed that a continental mass resting on the plates have been wandering throughout the geological period. Pangaea was a result of converging of different continental mass that were part of one or other plates or the other plates. Scientists using the paleomagnetic data have determined the position held by each of the present continental land masses in different geological time period. In 4.4 we have taken this one. So all these are like single plates, not single, like all these are like single units which got different along the time. Skull got different, drifted, and at one time of moment, like when it was vinegar acid by vinegar, it was all like a single landform. Mostly Peninga is traced with the help of rock analyzed from Nagpur area. Okay, the position of Indian subcontinent, mostly peninsular India, is traced with the help of the rock analyzed from the Nagpur area. There are three types of plates boundaries. Transform boundaries. Okay, yes. One by one. Divergent boundaries. When new crests are generated as the plates pulled away, when the plates pulled away from each other, like they are pulled diverging, like they are separating apart. The site where the plates move away from each other is called spreading sites. The best known example of the divergent boundaries are mid-Atlantic ridges. At this, the American plates is separated from Eurasian plates and African plates, convergent boundaries, where the crust is destroyed as one plate dived into another. Like basically they are converging. The plates are getting destroyed and converging, like shrinking and all. So the location where shrinking of the plates occurred is called subduction zone. Mhm. The location where the shrinking of plate occurs is called subduction zone. There are three ways in which convergence can occur. The first is uh, three ways. The first one is oceanic and continental plates. Second is between two continental plates, and third is between two continental zones, like two continental plates. Sorry. Transform boundaries, where the crust is neither produced nor destroyed as the plates slide horizontally past each other, like they are sliding. And the transform faults are the planes of separation generally perpendicular to the mid of oceanic ridges. As the eruption do not take place all along the entire crest at the same time, there is differential movement of a portion of the plates away from the axis of Earth. Also, the rotation of Earth has its effect on the separated block of the plate portion. How do you think the rate of plate movement is determined? Plate, how do you think the rate of plate movement is determined? The strip of normal and the reverse of the normal and reverse magnetic field that parallels the mid-oceanic ridges help scientists determine the rate of plate movement. The stripe of normal and reverse magnetic field that is parallel to the mid-oceanic ridges help scientists determine the rate of plate movement. This rate varies considerably. The Arctic regions have the slowest rate. Arctic regions have the slowest rate, less than 2.5 centimeters per year. East Pacific rises near the eastern island in the southern Pacific, about 3,400 kilometers west of Chile, has the fastest rate of more than 15 centimeters per year. The force for the plate movement. At the time that Wegener proposed this theory of continental drift, most scientists believed that the Earth was solid, motionless body. However, concept of sea floor spreading and the unified theory of plate tectonic have emphasized that both the surface of Earth and the interiors are not static or and motionless but dynamic. They are dynamic. But the interior of the Earth as well as the surface of the Earth are dynamic. The fact that the plate move is now well accepted fact. Mobile rocks beneath the ridges have the plate is to be believed to be moving in circular manner. The mobile rock that is beneath the ridges plate is believed to be moving in circular manner. The heated material rises to the surface, spreads, and begin to cool, and then sink back into deeper depth. This cycle is repeated over and over to generate what scientists call a convection cell or convection probe. The heat within the Earth comes from two main reasons. First is radioactive decay, and the second is residual heat. Arthur Holmes first considered this idea in 1913, which later influenced the which later influenced Harry Hess's thinking about free flow spreading, the slow movement of hot and soft mantle that lies below the ridge's plate is driving force behind the plate movement. Movement of the Indian Ocean. No, sorry. Movement of the Indian plates. The Indian plates includes peninsular India and the Australian continent portion that we saw, and also like in some of New Zealand also. Okay, that is what I was talking about. Like these are a similar the part of India got gifted and it got attached to the now we call that's Eurasian plate, and due to which fold mountain was created when it got attached here, like so-called Himalayas and all Himalayan ranges. This is due to this continental drift. The continental drift, not basically this plate drift. The Indian plate. Forming the okay. The subduction zone along the Himalayan forms the northern plate boundaries in form of continent. Continent convergence. Continent convergence. Convergence. In the east, it extends to Rakhine mountain of Myanmar toward the island arc along the Java trenches. These parties. The eastern margin is a spreading side lying to the east of Australia, east of Australia in the form of oceanic region in Southwest Pacific. The western margin flows from Kathithar, uh, Karith, Kirthar mountain of Pakistan. It further extends along the Makrana coast and joins the spreading side from the Red Sea Rift of southeast and along the Chagos archipelago. archipelago. The boundary between India and Antarctic plate is also marked by oceanic ridges, the divergent boundaries, running in rough southwest direction and merges into a spreading side, a little south of New Zealand. Talking about this one. Okay, we got to see tower trends, and if we go here, we'll see. Okay. India India was a large island situated off Australian coast in vast ocean. The TTC, the TTC separated it. TTC, the tides, the Thai seas separated it from the Asian continent till about Asian continent till about 225 million years ago. India is supposed to have started her northwest journey. Uh, India is supposed to have started its northward journey about 200 million years ago. She separated it from Asian continent till about it now, and again India is supposed to started moving toward what we now call is whole Asia, which like this one journey, it took almost 200 million years ago. At a time when Pangaea broke, India collided with Asia about wait. I got confused somewhere. The boundary between India and Antarctica was also marked by ocean ridges diverging running through also merging into spreading site a little south of this. So, these are like very confusing ones. India is a large island situated off Australian coast in vast ocean. The tides separated from Asian continental about 25 million years ago. It was separated. India is supposed to have started moving toward what we call now Asia. Then 200 million years ago, it started moving, and finally, it collided with Asia about 40 to 50 million years ago, causing a rapid uplift of the Himalayas. Basically, it made the Himalayas, and it was also called four mountains. The position of the Earth, the position of India since about 71 million years till the present are shown in this one. It also shows the portion of India's subcontinent and the Eurasian plates. The Eurasian plate, this one, on which it got crashed literally, but it took millions of years to crash into Eurasian plates. To the equation of aliens of and the Eurasian plates. About 140 million years ago, before the present, the subcontinent was located as south, south 50-degree latitude. Okay. The two major plates were separated by Tide Sea, and the Tibetan bloc was closer to Asiatic landmass. During the movement of Indian plate toward the Eurasian plate, a major event that occurred was outpouring of lavas and formation of Deccan traps. So during the movement of Indian, so I'll get it with how the this will get me the question like how these Deccan traps are made, not made, like what were the major event happened during leads toward that the major event that occurred was outpouring of lava and formation of Deccan traps. This started somewhere 60 million ago, 60 million years ago, and continued for a long period of time. Note that note that the subcontinent was still close to equator. Note that the subcontinent was still close to equator from 400, from 40 million years ago. Thereafter, the event of formation of Himalayas took place. This due to in this time period, Himalayan formation of Himalaya took place. Scientists believe that the process is still continuing and the height of Himalaya is rising even to this day. Like still, this is crashing into Eurasian plates, which Indian plate is crashing. Still it is crashing till now. So it's complete. So let's mark something. Who among the following was the first to consider the possibility of Europe, Africa, America have been located side by side? Side by side, who the first? Maybe. Let's see. Wagner. So I'm getting the spelling wrong. Wagner or Winning. Wagner sounds more. Continental drift. Who proposed the possibility? Yeah, it's not Wagner. No wonder many scientists thought the similarity. Suppose observe the coastline, you may perhaps material. No wonder. Similarity consider the possibility of two America, two America, Europe, and Asia to be once joined together. From known record of history of science, it was Abraham. Let's mark this as this. Many scientists sort of consider the similarity level cost. Wait, make it good. The possibility of two Americas, Europe and Africa to be one together from the known record was of history of science was Abraham Ortelius, Ortelius, Ortelius. A Dutch hatmaker who first proposed such possibility as early as 1596. Okay. Next was Antonio Pellegrini, who drew a map showing the three continents together. However, it was Alfred Wegener, a German meteorologist, who put forward a comprehensive argument. He proposed an argument for continental drift theory in 1912. So let's write this. Abraham Ortelius, Ortelius Ortelius. Is what Paul can possibility of Paul, CONTI and the continents are joined. And the past. And what did Alfred say? He gave the theory of continental drift. Wagner. It was this one, Abraham, first to consider possibility. He was first to consider, there were many scientists, but he was first documented. Family anti-documented record. Polar fleeting forces are related to polar fleeing forces. Polar fleeing. This was not revolution. This was rotation of Earth somewhere. Polar. Where is it? Two rocks of same ages. Sediment Gondwana, 69 muscles, Gondwana system and sediment in polar fleeing, distribution of policies, force of drifting, yeah. This was a polar fleeing, pole fleeing. This without green was okay. Wellness is the movement of responsible for the drifting of continent was caused by pole flowing forces and tidal forces. Pole flowing forces related to rotation of rotation of Earth. See. We are aware of the fact that the Earth is not perfectly straight. Okay, we read that. The tidal force is due to attraction, and it is the second force and first force. Both is rotation of Earth. So this is. So we could have two answers. That is the rotation of Earth, not the rotation of Earth and tides. Was tide force of tides. Rotation of Earth and tidal force. Tidal force. Which one of the following is not a minor plate? Antarctica is not a minor plate. This is a small area. Is not a small. Antarctica is very big one. Let's come from this. Okay. Yeah, this is Antarctica. You see these are the divergent boundaries and which make the whole this region like it's yes Antarctica. Wait. Which one of the following fact is not considered by those which one of the following fact was not considered by those while discussing the concept of sea floor spreading? Study. Following fact was not considered by discussing the concept of sea floor spreading. Age of rock from distribution of fossil and I guess this one type of novel and because magnetic rocks are from yeah this was there volcanic activity in middle this is the main thing due to which age of rock from which one of the fact was not considered while discussing the previously spreading of flora. This background rock on either side of the rock mysteriously appear an eruption of constant eruption is a cause. Ocean crust new various positions ocean crust on either side the ocean floor spread is the younger age of oceanic crust as well the fact that spreading of one ocean does not cause the shrinkage of another made hence think about the consumption of oceanic crust is got to maintain the ocean floor that get pushed due to volcanic eruption at the sediment the ocean doesn't. This is one more was there basic concept of sea floor spreading as the term this is not concerned has been declared 4.3 okay 3 so distance magnetic ridges. Okay, magnetic property is also there to determined by normal polarity and normal polarity and ocean crust and ocean the rock of ages is also sediment and very ocean full of unaffected okay, I got the answer. Yeah, I just which one of the following which one of the following which one of the following is a type of plate boundaries of Indian plate along with the this one is not divergent is it divergent convergent, like it's converging into one, like it's crashing, and that's why it's converging into crashing in a sense into variation plates. That's why it's called. So it's converging. Like this is an easy one. It's quite logical. So the ocean, no, continent to continental convergence. What will the force suggested by Wegener for the moment of continental? For the 30 more, we take a rotation of and tidal forces, tidal force. What are the convectional current in the mantle image? What are the conventional current in the mantle initiate? What are the conventional current in the mantle? How? Wow, wow, wow. How are the conventional current in the mantle initiated and maintained? Conventional current are initiated due to asthenosphere and lithosphere, like when they are conventional current in the mantle are initiated due to tectonic plates crashing. Due to existence of okay. Arthur Holmes discussed the possibility of convection current operating in a mantle portion. Okay, these are due to radioactive element causing thermal differences in the mantle portion. These currents are generated due to radioactive elements causing thermal differences in the mantle portion. These current these this more slightly more defined. Tissue can review this get to 2025. So, conventionally, these are generated due to differences due to thermal difference due to THPR in the mantle portion TPL MEN TPL mantle metal. I don't think this type of question will come in exam at all. Like these are like discussed. These are the possibilities, are the theories. MNT mantle portion such currents in mantle. These are generated due to radioactive element causing the thermal. Radioactive element determined caused by in the mantle by and TL mantle by radioactive radioactive elements What is the major difference between the transform boundaries and the between transform boundaries and the conversion and divergence boundaries? Conversion boundaries, like they are crashing into one another. These are separating. The divergent boundaries are separating two boundaries. That's all. And the transform boundaries are like the volcanic eruption, which are literally making mountains in oceanic floor. What are the types of what was the location of Indian last landmass during the formation of Deccan Traps? Location of Indian 50 degrees south. See, let's see. Somewhere here. No, somewhere here. Yeah, it was 50 degrees south latitude. Yes. India, the USA was okay, during 500 million. During the two major tours were separated by trades and was towards duration rate major event that occurred during the outputting of lava and formation of Deccan Traps. This started somewhere 15 million years ago and continued for a long time. Note that the subcontinent was still in close to equator. Close to equator. It was not there. It was close to over equator. Supporting the continental drift. Similar land masses like 6 of Saturday 6 of 6 of light placement of continents. This was the main advance. Bringing about the basic differences between drift theory and plate tectonics. What are basic differences? Basic differences. What can be the basic differences? Basic differences, the force of the train, the distribution of earthworks, yeah. Post theories. Okay, jigsaw fit was mostly matching with the lights sedimentary or found. There was only one evidence. And second, place of deposition distribution of fossils was also for 30 marks. It was for 30 marks. No. That's for 150 marks. Number one. Matching continents, delights, sedimentary rock found in the deposition of glaciers, Gondwana system of sedimentary of India known to have the counterpart of different land masses of southern hemisphere. So this was one more education. There's a deposition and distribution of fossils. So there is four basic ideas that give support to the continental drift theory. Next one is force of drifting post-drift studies. So this will take time. I'll find Google. Find in Google a more accurate one. What are the major project theory that is united the interest of scientists? Closely theory that is united the interest of scientists in many in the study of distribution ocean continents. So,